Hello, I welcome you to another session of MA 176, that is Probe and Stats. Now, from the beginning of the semester, we've looked at so many things, starting right from Introduction to Statistics. We also go to see something about descriptive statistics, where we got to see so many numerical measures as well as graphical figures for describing data sets. But for the purpose of this section, we'll be looking basically at the third chapter, which happens to be probability. So once we are talking about probability, I believe it's something which is not so new. You guys are used to this probability term, although you might not be aware, but to a certain extent you guys have been using it unconsciously, and we are going to look at that. So in this chapter, basically we are going to introduce ourselves to some elementary probability concepts, indicate how to estimate probabilities as well as interpret them, and to as well show some rules of probability and see how we can apply them to compute the probability of many interesting events. So there are so many case studies in which we are going to consider under this section. So let's look at the objective of this chapter. That is, we are going to see how to understand and describe what we term as sample space events for random experiments. And also we are going to interpret probabilities and use these probabilities to calculate some interesting events in terms of discrete sample spaces. And we also look at what we call permutations and combinations, how to use them to count numbers of outcome in both events and as well as sample spaces. We are going to look at these as well. Now, once we talk about probability, it all refers to the study of random and uncertainty. Now, we see that in many situations in which a number of possible outcomes may occur, we are likely to use the term probability. So, in the term of probability, it's more or less about a discipline which provides us methods to quantify these chances or the likelihood of something happening in, let's say, a near future or something. So we are going to use this probability as a measure to estimate or quantify these chances, which event is likely to occur. So this is what probability basically is about. And although it is being used in the sense of mathematics, but informally, even in our normal language, in our normal communication, we've been using it informally, and today we shall look at some of them. So once it comes to the informal conversations, let's look at this kind of statements. It is likely that I will get an A in this course. Now, using this word likely, meaning that there's a chance in there. Now, although we might be using this unconsciously, but it is a form of probability. Also, other statement that there's a 50-50 chance that this incumbent government will seek re-election. Because of the 50-50 chances, that makes it a probability. Next, there will probably be at least one section of this course offered next year. The odd favor Chelsea Football Club. Those of you who have been betting on these sports games, we normally use this word, that is odds, and we are going to see how these odds play once it comes to probability. And also, finally, we can also look at this statement that it is expected that at least 20,000 concert tickets will be sold in a certain event. Okay, so these are all forms of statements that we have been making using just our normal languages, or we meet our friends, they'll talk about this. But at that very moment, we might not think this to be probability, but once it comes to probability, that is all that it is to know about this probability. But in this section, we are going to look at more or less like the mathematical aspect of it. So this probability dates back to about 300 years ago, where it started in connection. Once it came to solving of what questions involving games of chances. So although it started in that manner, But just as I said, our objective here is to cover the part that is subject to mathematical or statistical inferences. That is where we are going to estimate these probabilities to make decisions later. So that is what basically we are going to do. So before we move on into the whole thing, let's look at some terminologies. Okay, these are some terminologies that I'm going to use, and they are common ones too as well. You might have heard of them. So the first one that we shall look at is an experiment. Now, most of you are science students. Once we're talking about an experiment, you guys are familiar. It's all about an activity or process whose outcome is subject to uncertainty in this case. Okay, now we can also think of this experiment to be any process that generates a well-defined outcome. Now, although this word experiment suggests that it has to be planned or a carefully controlled laboratory testing situation, we use it here in a much wider sense. We are going to look at so many angles, not pertaining to these controlled processes, but we are going to generalize this experiment in our case. So for instance, we can think of tossing a coin once or several times. These are all forms of experiment. We can also think about selecting a card from a deck of 52, weighing loaves of bread, and also we can think of estimating or trying to think about the commuting time from our home to our workplace. So we could also think of the time we normally take to walk from our various hostels to the lecture rooms, or you just think between any two ends that you like to travel a lot. And also we can also go into the hospital where we get to obtain blood types from a group of individuals. These are all forms of experiment. And finally, once it comes to engineering, we can think of measuring the compressive strength of our metals or different beams. Okay, all these are forms of experiments. Now let's look at another one called the sample space. Now this sample space is also a popular term. Okay, it is used most often, very often. Now this sample space refers to all the set of possible outcomes of any experiment that you conduct. So in other words, we could say that it's a set of all experimental outcomes. Anytime you do perform an experiment, what are the possible outcomes? And this becomes our sample space. Now, for example, the simplest experiment to which probability applies to only one or two possible outcomes. We can think of so many. We can think of a single welding, whether those of you who have been, I don't know if any of you have had this experience to weld metal or something, or have been to the welding shop. You could see that anytime welding is being done, it could be that at the end of the day, the welding might be perfect or not perfect. In this case, we call it to be defective or not defective. So once we perform an experiment in welding something, at the end of the day, we could have a sample space that the welding that we did was defective or not defective. So in this case, we are just representing our not defective by this N and our defective by this uppercase D. So these are the two possible outcomes. It could be that after the welding, the whole operation will be defective or not defective. So these are the sample spaces that could arise from welding of any metal or material. We could also think of tossing of a thumbtack. Now once we talk about a thumbtack, it's all about this pin that we normally paste posters on our notice board, and this is how it looks like. This is just an example or a picture of this thumbtack. Now suppose that we throw this for it to come and land either on the floor or on the table. There are two possible outcomes. It could be that it will land or point up or point down. Okay, so these are the two possible outcomes, whether it's going to point up or point down. So this is also an experiment with sample space with only two sample space. Also, we can think of observing the gender of a population or the next child born at a certain local hospital. Now once it comes to gender, we know that we have two, that is either a male or a female. So if you should conduct an experiment observing the gender of the newborn child, we are just going to have only two outcomes, that is either the baby is going to be a male or a female. So this is how sample space are. But let's look at situations where we will have, let's say, more than one, three. So in the case of one that more than two sample spaces, let's take for instance the welding operation. Now for this welding operation, you see that if we decide to weld three materials in sequence, now we take first material, we weld it, we take the second one, we weld it, we take the third one, we weld it. Now in this case, we are going to have multiple sample space because we are welding in sequence, that is three. We are going to have what? Three, should I say three units per each watt sample or per each watt event. Now it could be that the first welding will not be defective, second also will not be defective, and third will also not be defective. It's also likely that we can have the first one not defective, second one not defective, but the third weld might be defective. It could also be that the first weld might not be defective, the second welding will be defective, while the third will not be defective. So we can continue until we get to this last event, where it could be that all the three sequence of welding will be defective. So once it comes to welding three materials all in a sequence, it's likely that we can get 1, 2, 3, 4, 5, 6, 7, 8 samples for this welding operation. Now in that same way, we can think of tossing of this thumbtack 3 times. Now if we do that, we're also going to get something similar to the one we have up here, just that in this case we are going to have N and the U instead of the D. So in this case, just as we have in here, we can just replace our N by our U, which refers to up, and our D just will refer to our down. So once we have this is also going to give us something similar as we have here in the case of the thumbtack. Now similar thing is also going to reach itself once it comes to checking for the next 3 born new child, new children, and all this is just going to give us something similar. It's a male and female. So we're also going to have something similar just as we have in here. So this is how the sample space works. So this sample space refers to the possible outcome that could arise out of any experiment. So with this, let's try to take a live example and see what happens. Now you know that for those of you who have been in Takwa or who knows Takwa's too well, you know that we have several gas stations in this municipality, but in this case, let's take a look at only 2. So suppose that 2 gas stations, let's take Shell and Goil. This happens to be the major ones here. Now these 2 stations, each of them has 6 gas pump each. So once you should visit any of these stations, each station has 6 gas pump each. So suppose that we are considering an experiment in which the number of pumps in use at a particular time of the day is determined for each station. Now all that this experiment is trying to do is to just show the outcome, the number of pumps that will be in use per a particular time. So in this case, we can come up with a table just like this. Now in this table, we could represent this first part to be our first station, and this upper part to be our next station. So this first station could either be Goil or Shell, and this second to in that same case. Now remember that for each station they have 6 pumps. So you can see that we have 1, 2, 3, 4, 5, 6. For the second station to the same thing, 1, 2, 3, 4, 5, 6. Now it could also come that there might be a time in which at a particular station no pump will be in use, and that is where the 0 comes in. The same thing happens to the second station too as well. So once it comes to the number of pumps that is being used at these 2 stations at a given time, it could be that by the time that we will be looking or conducting this experiment, no pump will be used in the first station, and as well no pump will be used in the second station. Okay. Now once we move to this side, it could be that at the first station no pump will be used, but once we get to the second station, one pump will be used in there. So in this case too, similar thing happens until we get to a situation. Perhaps it could be that all the 6 pumps will be used at the first station, and all the 6 pumps will be used at the second one station. So these are all samples or sample spaces that we could come up with once we are dealing with the usage of 6 pumps at each of these two gas stations. So with this same thing, let's try to look at throwing of a die, and in this case we are throwing this die twice. That is the experiment. Now with this experiment, it could be that for the first throw we could get 1, and for the second throw, throwing it for the second time, we also get 1. In that same case, it is likely that we could have an event where for the first throw we get 1, and for the second throw we get 2. So this continues until it gets to this last portion that we have here. So it could be that the first portion or the first throw we get 6, and the second 6 we get the second throw we get 6. Now this is much desirable once you are playing this Ludo. Okay, normally you would prefer to get multiple 6. So that is also something there, but these are all experiments, and that is what we are dealing with now. So you can see that in this case, once we count the number of events, we have about 36. That is about 36 sample spaces. But let's look at the previous one, and the previous one will be somewhere about 46. So all this, we have about 46 outcomes, and this represent our sample space. Okay, so for the gas pumps we are having 46 outcomes, but once it comes to throwing a two-sided 6-sided die, throwing the die twice, we get to come up with 6 outcomes. Now let's look at also another interesting one. Now, back in first year, you guys did something on procedural programming with C++. Now, although you guys are new to the whole programming thing, but one thing that is common is that for beginners, it's like very difficult to get your program to compile at the first time. Okay, so at times you are going to run for the first time, it's not going to run. You are going to run for subsequent time before you get to get a hang of it, before you try to achieve some success. So in this C++ programming example, now we are trying to look at that. Suppose an experiment consists of selecting and compiling C++ programs at this university one by one until one encounters a program that compiles on the first run. So in this case, we are going to denote a program that compiles on the first run by S. That is, if you are able to run this successfully, you represent it as S to represent success. Now on the other hand, if you run and it doesn't run, it means that you failed. So in this case, we are going to represent it by an F. Okay, so in this case, once it comes to running of this C++ program, there's bound to be multiple outcomes. Okay, it could be that one person will run for the first time and is going to succeed. Someone also is going to run for the first time, will not succeed, but for the second time might succeed. Someone is going to run for about 10 times before he even succeeds. So with this, you can have so many different outcomes. But with this particular example, we are going to dive more into this later in the course of the lecture. Also, another popular terminology is the word event. Now, once we are talking about event, this event happens to be a collection of subsets of outcomes contained in the sample space. So in this case, once we pick a sample space, any subset, you guys do remember your set, any subset, that is any of the events or any of the outcomes within the sample space, if we should select any of them to be our subset, then that happens to be an event. So in events, it's all about a collection of the sample points within the sample. Once it comes to this event, we have it in two forms. That is the simple and as well as the compound event. Now with a simple event, it consists of exactly only one outcome. And in cases where we have multiple outcomes, then that becomes what? Our compound event. So for the simple, remember it only consists of one outcome. But for a compound, we have more than what? One outcome. So let's take a look at an example demonstrating these types of what events. So consider an experiment in which each of three vehicles taking a particular freeway exit either left or right at the end of what? The exit what? Ramp. So in this case, suppose that we have this freeway. Forgive my drawing. Now at the end of this freeway is either you go left or you go right. Yeah. So either you go this way or you go that way. Now this happens to be our right and this happens to be our left. So in this case, remember from the question, we have three vehicles coming. Now with these three vehicles coming, now it could be that the first vehicle will go left, second vehicle will go left, as well as the third vehicle going what? Left. And that is being represented by what we have here. In that same case, the first vehicle could go right and the remaining two vehicles could go left. That is what we have here. In that same fashion, others too could go the direction, and all this has been represented as the sample space that we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So in this experiment, we are having what? 8 samples, and this is what we have, and this happens to be our outcome, and this whole of this represent our sample what? Space. Now let's look at something. For instance, suppose that we would like to know what the simple events are. Remember that the simple event refers to what? Only what? One outcome. So suppose that we take any of these what? Outcomes, that is going to be what? Our simple event. So in this case, suppose that event 1, we are only taking only the first outcome here. That is a situation where all the three cars goes or exit at the left turn. It means that for this to happen, that it will be the only condition where all these three cars will be going to what? Taking the left what? Traffic. So once we have LLL in here, so this LL, picking this one alone refers to what? A simple what? Event. In that same case, we could also think of a situation whereby the first car exit at the left and the second or the remaining cars exit at the right. And that can be estimated or that can be deduced from the fifth, that is the fifth outcome from the sample space. So once we are looking for a situation where that occurred, it means that we are going to pick only what? This fifth one, and that is only going to be what? A single outcome, and that makes it what? A simple what? Event. Now let's look at the compound ones. So suppose that the events, we are looking for the event that exactly one of these three vehicles turns right. The event that exactly one of the three vehicles. So in this case, we are looking at a situation whereby only one of the vehicles turns right. Now looking at the sample space that we have, the only situation where only one car turns right is the one that we have this, and that constitutes what? Our event. But for this event, you could see that it's more than one, and that makes it what? A compound event. Also, we could also think of an event that at most one of the vehicles turns right. Now this is an English word, at most, meaning that not more than one car turns what? Right. Okay. So it could be that a car or with the three vehicles what? Moving. It could be that only one car turns right or no car turns right at all because of this term at most. This is an English word. And the only situation where this could occur is when we have these events. And with this case, you could see that only one car or at most only one vehicle turns right. And this is a situation where no car turns right at all. Okay, so in this case of an event that at most only one of the vehicles turns right, is being the event is being correlated here. Then because this event contains more than one outcome, that makes it a compound event. Now let's look at another one, the event where all the three vehicles turns in the same direction. And for that to happen, it means that all the three vehicles will have to go either left or all go what, right. And because there's more than one, that also makes it what, a compound event. Yeah, and also that is that. Okay, now suppose that when the experiment is performed and the outcome is left left left, then the simple event E1 has, and so also have the event B and C what occurred, but not what A. Okay, remember that we have left 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 in here, left 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 in here. So if that happens to be, it means that this event B and C has, but because we don't have this left 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 in here, this event A has no what. So let's take a look at example. Now, revisiting the gas stations scenario. Now, suppose that when the number of pumps in use in each of these two gas stations is observed. Remember that we had 49 possible outcomes. So if we are to take these outcomes one at a time, it means that we could have what, 49 simple events. Now, once we are talking about this 49 simple event, it could be that for a particular event, we could have 0, 0, that is no pump will be in use. We could also have 0, 1, and this will continue until it gets to what, the last event of what, 6, and what, 6 pumps all in use. Now let's think about the compound events. Now with the compound events, we could see that suppose that we are considering the event that the number of pumps in use is the same at both stations. Now for this to be realized, it means that the number of pumps being used at station 1 should be the same as the number of pumps being used in station 2. And this is simple. And for that to happen, it means that it could be that 0 or no pumps will be used in both pump station. It could also be that station 1, 1 pump will be in use, and once it comes to station 2, 1 pump. Now it will also be that 2 pumps will be used each at these stations, or 3 or 4 or 5 or 6. So this is the only situation where equal number of pumps will be in use at both stations. And once we have, because this event is more than one, that happens to be what, a compound event. We could also think of a situation whereby we like to look for an event that the total number of pumps being used in both of what, these stations is what, 4. So once it comes that we could do so many what combinations. It could be that at station 1 no pump will be in use, but station 2 4 pumps is being used. Now remember the event that the total number of pumps being used is what, 4. Emphasis is being laid on what, this number what, 4. It means that the combination or the total number of pumps that are supposed to be used in these two stations should be exactly 4. I mean the addition should give you what, 4. And so we could have 0, 4, 0, 3, 2, 2, 3, 1, and 1, 4, 1, 0. So these are the possible combinations or the possible outcome that could make this event come what, true. Okay, and because this event has more outcomes within, that makes it what, a compound event. Also, we can look at an event that at most 1 pump is in use at each station. Now because of this word, that is at most, meaning that there could be 1 or none at all. So we could have 0, 0, 0, 1, 1, 0, what, 1, 1. So these are all situations whereby we could split our event into simple and what, compound. Okay, now let's look at the C++. Now with the C++ programming, I'm using you guys as case studies. Yeah, so the sample space for this program compilation, that is with C++, in this case is going to be infinite Like there will be so many to count, okay? And you guys know yourself, at times you could even run for about 30 times before you even achieve a success, okay? So if you would like to look at this one by one, then we have it there, okay? Like suppose that we are looking for an event where a student runs or achieve a success after the second round, then we can take off what this, that is FS. Now because we are looking for an event where he achieved a success after the second round, it means that definitely for the first round the students is going to fail in running or compiling the program, but once he tries again for the second time, he achieves a success, okay? So if you are looking for that simple event, you could just choose on that. In that same case, we could think of so many. But once it comes to the compound event, we can think of the event that at most 3 programs are examined, meaning that once we take this event, you run for the first time, runs for the first and second before achieving that, but runs for 3 times before he achieves success. But before we are looking for at most 3, it means that there's no way the student should run the program more than 3 times. So that is also there. So that gives us this compound event. Now let's look at this one, the event that an even number of program is examined. And once we are talking about even number of program, it means that either the person or the student runs the program 2, 4, 6. You guys know your even numbers. So the first instance, you could think of one where the student run for the second time before achieving a success. You could also think about the time where he runs about 4 times before he achieves a success, and the next one happens to be 6 and 8, 10. It continues that way. So most of the time when we are looking for this, always think about the condition that we are looking at. So remember, in this case, the event that an even number of programs is in what examined, and in this case we are given what even numbers only. With this same event, you could rephrase it as what odd numbers of what programs have been what examined, and this can also come in handy. So these are that. So this is the difference between, we've looked at experiments, we've looked at sample space, and we've looked at what events, where we have the simple and what the compound event, okay?